The lesson today is about solving systems, and we're going to use our matrices in order to solve the system. So step one is writing something called an augmented matrix. So let's say we have this system right here. We're going to make a matrix out of that. And this isn't a matrix equation, it's a single matrix where we put the coefficients and then we sort of put that answer over on the side. So we're going to call that the augmented matrix. So that's the first thing. And so if you see an augmented matrix, you can go backwards and you can write the system that corresponds with that. So this one was a smaller matrix because it was a smaller system. Next. Remember when we learned about Gaussian elimination? Doesn't this remind you of Gaussian elimination where that whole bottom corner is sort of cleared out? So this is a matrix that's in row echelon form. We talked about having our system in row echelon form last chapter. And actually, his matrix right there is the same thing as writing this. That's just an augmented matrix that represents this system. And you can see that he's got that triangle of opportunity all cleared out, ready for back substitution, right? Yeah. Now, I like to reduced row echelon form takes that a step further. It takes Gauss's 3 zeros, and I like to imagine that this Jordan guy comes along and he clears out this top triangle as well. And so Gauss-Jordan elimination leaves us with a system that just has like 1x equals 4 and 1y equals 6 and 1z equals 7. And so if you can get both of these triangles set up as zeros and the diagonal as ones, you actually have already solved for x, y, and z. So that's what we're going to be working on, is using Gauss-Jordan elimination to write our augmented matrix in reduced row echelon form. That's a lot of big words, but I think it's going to be a pretty simple process since we already know how to do the Gauss stuff. All right, step one, we're going to write that again as an augmented matrix. So we're ready to solve this system of equations using Gauss-Jordan elimination. Step one is to set it up as an augmented matrix. And I kind of like this method better than how we did it last chapter because you don't have to write those letters every time. It just saves that extra step. So here's our augmented matrix, and we're just going to do those regular old row operations just like we did with Gaussian elimination. So I like to start with maybe this 2 and eliminate that, and then the 3, and then the other 2. So let's try the 2. I think multiplying the top row times -2 and adding it to the second row would be a good idea. And if you just kind of want to keep track, you can either do this off to the side, or I'll just show that I'm going to multiply this row by -2 right here. And so then I'm going to add that to row 2. Now when I write my new augmented matrix, I'm going to keep that top row unchanged. I could throw the -2 in there if I wanted to, but it just makes the numbers bigger, so I'm going to leave it. And then my middle row gets replaced because it's the 2 I was trying to eliminate. So I'm going to do -2 plus 2, -2 plus -1, -2 plus 3, and -26 plus 9. All right, we're a third of the way to Gauss. Now Gauss is going to get rid of the 3. We're going to take -3 and add it to the bottom row. Here we go. So in my new matrix, the top will stay the same, the middle will stay the same, and just that row 3 is going to change. And it's going to change because I'm going to multiply that top row by -3 and add to that bottom row. So -3 plus 3, -3 plus 2, -3 plus 1, and -39 plus 38. Sweet. Gauss needs to get rid of that. You know, it seems like using the top row would be a good idea until you realize that if you combine the top with the bottom row, you're going to cancel out your 0 you just got. So it's actually smarter to use the middle row instead, which means I'll multiply that bottom row by -3, but I'm going to be replacing the bottom row, right? So top row stays the same. Middle row stays the same. And I'm going to multiply bottom row by -3. So that turns this into a 3, and that into a 6, and that into a 3. And I'm going to add second row to that. So well, I guess this one is a 0. So 0 plus 0 is 0. -3 plus 3. 1 plus 6. And -17 plus 3. And Gauss is done. He has got his little triangle of opportunity. The one thing I might do just to make the numbers smaller, if you ever see an opportunity for this, you can totally multiply a row by a fraction just to reduce the entire row down to smaller numbers. And actually, in this case, we already know that z is equal to -2. So that would have been good enough if we were going to do back substitution, but we're going to take this a step farther, remember, because now Jordan is involved, and Jordan's going to clear out the other triangle, right? And I have an order that I do those in too. I like to go this one, then this one, then this one, sort of in the opposite order from the Gauss. So if I want to get rid of this one, should I use top row or bottom row? And I would go bottom row. Otherwise, I'm going to start messing with my 0, right? If I use the bottom row, a 0 is not going to mess with the 0. So I think I'm going to do -1 times my bottom row. And add that to my second row. Here we go. Top row stays the same. I'm not going to change that bottom row, but I multiplied it so I could add. So 0 plus 0 is 0. 0 plus -3 is -3. -1 plus 1 is 0. And 2 plus -17 is -15. And we're looking good. And I think I'm going to go ahead and I'm going to reduce this row by a factor of -1/3. Just to make the numbers smaller and easier to work with. I also like this because we're starting to get those 1s down the diagonal. The 1s down the diagonal. And that's what reduce row echelon form requires. So we're getting closer. All right. And now we need to make this one go away. So I think the bottom row is the obvious choice. We'll probably want to multiply it by -1. So we'd have 0, 0, -1, +2. Middle row and bottom row I'm going to keep unchanged and only changing the one that I'm targeting. So I'm going to do 0 plus 1 is 0, 0 plus 1 is 1. Did I say that wrong? -1 plus 1 is 0, and 2 plus 13 is 15. And we are one step away. Here we go. Jordan completes his upper triangle of opportunity by eliminating that 1. I think a nice way to do it would be to take the middle row times -1 and add her up there. So this would still be 0, but a -1, a 0, and a -5, right? All right. Middle row, I'm going to keep it how it was. Bottom row, keep it how it was. And just my top row becomes 0 plus 1, -1 plus 1, 0 plus 0, and -5 plus 15. And that is reduced row echelon form. It's got the 2 triangles of zeros, and it's got the 1 on the diagonal. Doesn't that even look like the identity matrix? That's exactly what we were shooting for. This stands for the system x equals 10, y equals 5, and z equals -2. If you want to write that as an ordered triple, you certainly could. And that's the solution to our original system. Now this last system is a total beast. It's got 4 equations and 4 unknown variables. And if we were going to Gauss-Jordan this, goodness, we'd have to clear out this entire triangle. And we'd have to clear out this entire triangle. And I think that would be about 12 steps. So on something like this, I would let you use your calculator. There is a way to get this into reduced row echelon form on your. So step 1 is going to be to get that beast of a matrix into your calculator. And I already have it in. It's a 4x5 augmented matrix. All the numbers are entered. You want to go out to your blank screen, and then under matrix again, so second matrix, we're going to do some math to that matrix. And if you keep going down, there's all kinds of things that we don't even know about yet. But here's row echelon form, and here's reduced row echelon form, which means that that's the Gauss-Jordan. So we're going to use reduce row echelon form. Second matrix of matrix A is where I had it entered. And when I push enter, it automatically, look at that, all the Gauss zeros, it's in reduce row echelon form. And so then I can say that x equals that, and y equals that, and z equals that, and w equals that. Now the biggest limitation here, even though that was super sweet, we have an answer after just a little typing on our calculator. The biggest limitation is that this method only works for linear systems, and that means once you start throwing in squares and logs and things, the Gauss-Jordan system doesn't work. But as long as it's a linear system, I think this matrix, augmented matrix thing is a good way for solving those.